Let's wait for a couple of seconds. Hello, everyone. This is Milan again, and it's my pleasure to introduce you my colleague Krasimira, who is solution architect with Ontotext. She will reveal our current job and progress with the Ontotext knowledge graph and the whole approach behind it. Kras, it's your turn.
Hello, everyone. Thanks for joining. And let me share my screen. Sorry. So welcome to our presentation, where we'll tell you how we're building a knowledge graph about Ontotext and combining it with the power of large language models to enable our marketing specialists to do their best work. So let's walk you through our journey. So how did it all start? Well, it started with the desire of our marketing team to make the content on our website easily discoverable. And over the years, we've helped many organizations to get the most out of the content they produce with the help of our products and services, which made this even more compelling for us. And we know that this requires more than a simple search interface alone. So we knew we were delving into how to enhance our content publishing processes with the help of our technologies. And somewhere along the road, when we saw the potential of what we started to build, we got greedy. So this grew into how to model all the knowledge we produce inside Ontotext in a single graph, so that we can eventually benefit the entire organization. And this is how we got into the Ontotext knowledge graph. So we'll tell you what is the Ontotext knowledge graph, we'll do a quick demonstration, and we'll see what lies behind it. So Ontotext knowledge graph is, of course, at its core, a knowledge graph, which models information about Ontotext combined with content produced by the Ontotext teams. And as I mentioned, we started with our marketing content. But it's actually more than that, as it integrates a set of workflows for data and content management. And the goal is to generate a knowledge space where knowledge is easy to find, reuse, and understand, and actually the source of knowledge-driven insights. And this is a very interesting project for us, as it is a cross-department project, and as such, it brings various advantages to us. So first of all, we benefit internally from our own expertise. We apply the products that we develop and the experience that we've gathered over the years to bring value internally, which is really motivating for us. And we are early adopters of the features that we introduce. So we are the first to test out how the new versions of our products actually fit real world scenarios. And we integrate and generate feedback for improvements of our products. And being cross-functional team gives us the freedom to actually experiment with various innovative approaches more quickly. So by putting engineers closer to the end users, we are able to do short iterative cycles where we quickly prototype, and we are able to assess the value of innovative ideas quickly. And as an additional benefit to all of this, we decided to expose this project as a public demonstrator. So let's see what we've got. As I stated earlier, in the Ontotext Knowledge Graph project, our main goal is to make the information about Ontotext easily discoverable, which means that we need to extract the value that is locked inside our content and make it accessible. So we start from the bottom with applying our standard methodology for such kind of projects. We start by defining competency questions to guide us what we need to model in our graph. And we built a knowledge graph, which consists of custom ontologies as an extension of schema.org in our case, and custom taxonomies. And we store that in GraphDB by leveraging standard tooling for knowledge graph management. And we use Ontorefine for transformations from our structured content. And on top, we apply semantic content extraction using text analysis based on the defined vocabularies via the Metadata Studio. So I hope you've seen the presentation about the Metadata Studio yesterday, where we showed how powerful it can be by combining the graph-driven text analysis based on the entities in your own knowledge graph with external text analytic services such as large language models to discover new facts which are not yet in the graph. And with the Metadata Studio in OTKG, we classify our content according to the defined model and the entities of interest, so we can benefit from an integration with ChatGPT for targeted information extraction, for example. And this classified content we expose via flexible semantic faceted search, for which we use Metafactory. And having this all information placed in order and laid out nicely, it enables us to integrate with large language models for providing state-of-the-art knowledge discovery and exploration, which we'll see in a bit. And to actually make this valuable and usable, it is very important to us that the system is working with the latest content. So we've built workflows for our marketing team to maintain the data in the graph fresh and up to date with our website. And being a solutions unit on our end, we try to build this in a generic way so that we can easily adapt this to another organization that is aiming towards the same content management benefits. So if we shoot straight to the interesting part, how we integrated knowledge graphs with AI on each of these layers. During the cage building and semantic enrichment processes, we aim to boost the discoverability of our content both in search engines as well as in our platform. We aim to assign relevant link data during content publishing. For efficient content discovery, we of course need to be very precise with identifying the correct information the users are looking for. And to enhance their journey, we need to provide them with tailored navigation with relevant recommendations to build up their knowledge. And in terms of question answering, we aim towards exposing a natural language interface to consume the information in our knowledge graph in a user-friendly way. And the knowledge graph actually serves as a foundation for trends analysis and knowledge-driven insights. So let's see actually how this works. I am switching screens here, and I am showing the interface of the Metadata Studio, which, as I mentioned, we use for the semantic enrichment. So here we have our Ontotext knowledge graph project, and when I open that, I see the collections of all the documents that we have in our marketing content. In particular, we have blog posts, events, news articles, etc. So all the content that you can actually observe from our website, we have it here. And this is like the backstage of our marketing team that they use prior to publishing any new content to actually enrich that with semantic metadata. And if I open some documents just to show you how this looks like, so here we are able to observe. So this is a content about making GraphDB available on AWS Marketplace. And on the left, we see all the mentions which have been automatically discovered by the Metadata Studio tagger. So this here is a graph-based tagging. So the mentions here are not just keywords. These are actually the entities which we have modeled in our vocabularies. And thanks to the graph connectedness, we are able to classify our content with them. So they're ordered also by relevance. As we can see here, this blog post talks about AWS Marketplace and GraphDB being on it, so naturally Amazon Web Services is the highest relevant concept, followed by GraphDB. And for example, if I want to see, let's say as a marketing person, if I want to understand more about why this has been automatically added as a class to my document, I can open this annotation about cloud providers, and I can click on the highlight button here, and I see that the text actually shows me why cloud providers has been assigned. So in this case, it has been assigned because of the AWS mention, and because in our graph, we have the relation between cloud providers and AWS. So we see here direct application of the inference logic in our RDF database that, thanks to the connectedness in our knowledge graph, is able to enrich the mentions that we see. And so how are all these mentions used in practice? I am switching to another interface, which is like the end user targeted interface, where users can actually explore the end result of all of this. And we see our content here at the center and various filters available on the left. And we have here both standard filters, such as filters based on metadata that, for example, the type of the document, or when the document was published, or the author of the document. But we also see here a rich variety of additional filters. And these are actually our custom vocabularies. And we are able to filter based on these vocabularies. For example, if I expand here, we can see this is the whole tree that we have defined for industry. And thanks to these mentions, assignments, and content classifications, we are actually able to filter and better navigate the and find the content that we're interested in. So for example, if I filter blog posts that, let's say, talk about system operations, I see that the matches we have on the right, we have first our blog post that we examined through the metadata studio regarding the Ontotext being on the cloud, and we have the other results below. And if I open this, I see here that we can actually observe the tree of all the mentions that we have assigned via the metadata studio. And thanks to these mentions, we are able to also provide relevant content recommendations. So these are not just recommendations that rely on content, but these are also graph-based recommendations, which use these three mentioned to enhance on the plain standard content recommendation. I can also observe the notes in the mentions here. So for example, if I open our topic of system operations, I can see the definition of this topic in our knowledge graph. So we have defined this set of synonyms, we have defined what this concept means, and I can see here all the relations that it has and where it is mentioned in our content. I can also see some trends and analytics. These are the concepts, the other concepts from our knowledge graph that correlate with system operations the most. So, for example, I can see that we have mentioned knowledge graph management in our content very often with system operations. And these are like insights which have been made apparent and obvious to us thanks to containing all our data in a knowledge graph. So if we see any of these relations as meaningful, we can then proceed to add an actual relation between these two concepts. And if I go to the interesting part of all this and switch to the chat interface, which actually gives us a natural language interface of our knowledge graph, we can combine this with the filters on the left. So for example, I can filter my content by publication date, Let's say I want to focus on the content from the last 3 years so that I am sure that the response that I would get is relevant. And I can ask a question such as, what are the main benefits of using GraphDB on AWS? And we have integrated with ChatGPT here. So as we are waiting for the response of ChatGPT, let me switch back to the presentation to show you how this works underneath. So we basically enhance the standard retrieval augmented generation pattern by benefiting from the GraphDB ChatGPT retrieval plugin that comes to us as part of the 10.4 release, thanks to which we can easily transform our knowledge graph into embeddings and easily identify with very high quality what exact information we need to provide to the large language model to answer the user question. So this diagram depicts how our products have been chained to achieve the chat functionality. And we start on the left, where the user selects their content filters and sends their question to the system. And the request is consumed by our GraphDB database, where we have stored all the content enrichment metadata produced by the Metadata Studio on the right that we see here. And the user question and filters are sent to the chat application, which standardly retrieves the most relevant information to send to the large language model from a vector database. In this case, we use Waviet. But what is interesting is that the vector database has been synchronized with the content in GraphDB through a connector. So we gain a dynamic synchronization, meaning that when new information comes in GraphDB, it will be automatically updated in the vector database as well. So questions can be answered using new information straight away. So we enrich the response again with semantic metadata after we receive the response from OpenAI. And the user response is then contextualized with appropriate follow-up suggestions, as we're going to see now. Hopefully, hopefully we'll get the response. And here we can see that the response answers our questions about the main benefits of using GraphDB on AWS. So besides the standard information, it also gives us some insights, such as that it simplifies procurement, etc., etc. And what is interesting here is that we are actually able to limit the hallucinations that the large language models usually produce, which is one of the main problems with using large language models in production systems, by actually grounding the large language model with the reliable context that we send. So here we see these links, which actually point us to the content based on which this information is generated. So we're able to, this is our article as well. So we're able to trace back where the information comes from and to read further if we're interested in more details. And below, if I scroll down, we see here also a list of mentions, a tree of mentions, similarly to what we saw for the content that we have in our system. But here we have assigned these mentions on the response. So we apply text analytics based on the response. And thus we are able to place the user interest in the context of our knowledge graph by showing what are the relevant entities from our knowledge graph that the user is interested in. So we're also able to follow and learn more by reading the specific articles that talk about this topic. And so if we go back to our presentation, so we mentioned that these are our targeted areas in which we want AI to fit our systems. And how have we managed to achieve that with our products? So for quality tagging, we use the Metadata Studio for KG-aware text analysis over our content. For the knowledge discovery, as I mentioned, we use the GraphDB ChatGPT retrieval plugin connector for vector embeddings. And we use the GraphGB similarity index for the graph-driven recommendations. For question answering, we use large language models, of course. And for inferring new knowledge and insights, we make use of the graph connectedness and inference that help us to identify new knowledge and facts. And what lies behind the scenes of an LLM integration? So from our experience, we believe that large language models and knowledge graphs integrate naturally into a better package. In our project, we have applied a set of techniques for which we believe we address the major challenges with the usage of large language models in production applications, which are outlined here. So, for example, the fact that large language models are limited to public knowledge, we address by enhancing it with our own structured and unstructured information. The problem with hallucinations, we address by providing the large language model with reliable grounding context. And the lack of explainability and traceability, as we showed, we address by actually showing inline links to the actual content in the nodes in the knowledge graph, thanks to which this information was generated. And the internet is full of tutorials these days on how to implement the chat interface with large language models. But actually building a powerful natural language interface is far from trivial. And we've learned that going from providing grounding context to the large language model to actually elevating its performance requires some research and development. So let me share what we've encountered on our way. First, the problem with handling large texts is, of course, famously addressed by splitting the text into chunks, placing some windowing between the chunks, and indexing that as embeddings. However, when splitting the text into chunks, we usually result with lost context, especially for longer pieces of content. And we can also observe some noise in the original text or vagueness that prevents us to answer the question efficiently. So, for example, the answer of a question in a document can be scattered across different parts of the document. We refer to the challenge to match the user question to the correct content embeddings as the NASA problem. And this is because when we ask the question what US government agencies has Ontotext work with, the chat fails to match the text in which we actually mention that NASA is a client of Ontotext, and we fight that with query expansion and content enrichment. There are some query limitations. Of course, we are limited by how many content we can send to the large language model as part of the prompt. So, for example, when the answers to user questions are not covered by text alone, or when answering the question requires a broader view over the data, for example, for counting and aggregation queries like how many clients has Ontotext had over years, or if we add some filters for, let's say, how many clients from a specific industry has Ontotext had. So in these cases, you really need to find a way to extract structured information from the knowledge graph. And to wrap up, using large language models in an actual production system may not be as seamless as it initially appears. However, we see large language models and knowledge graphs together can bring really more value and can complement each other very nicely to unlock very exciting capabilities. And finally, the combination of knowledge graphs with semantic metadata, we believe that it can really enhance what large language model gives us for better discoverability, understanding, and insights. Yeah, so thank thank you very much, and handing over to Milan to facilitate any questions.
Thank you, Krasi. I see this presentation probably for the third time, and I'm always so excited when I go through the process with you together. There are no actually active questions. A couple of comments here about. Okay, so Atanas Kyriakov, we know him. He's asking to share your experience with prompt engineering, OTKG.
Yeah, well, this is a very long topic actually.
Yes.
But yeah, so some of the techniques that I mentioned that we try to address the major problems that we bumped upon actually include a lot of prompt engineering. So we have experimented with many prompts, for example, for reference resolution, for extracting targeted information retrieval, query expansion, not all of them successful. And what we can say is that it's kind of tricky because the prompts actually depend on the version of the large language model that you use. So whenever OpenAI release a new model, often the prompts need adjusting as well. But basically, it requires a lot of trial and error, and it's actually quite difficult to assess in a larger scale what is the quality of a certain prompt response. So that's why we rely on tools such as the Metadata Studio to actually help us with the evaluation of the quality in such cases, so that we mitigate the risk of quality regressions in the long term.
Okay, thank you. It was not so long explanation. I read Bob, who is asking internal question. Maybe we should address it internally, but should we open a new project into the Metadata Studio for the GraphDB documentation to add it to the graph, or you will answer this privately?
Yeah, we can take it over.
All right.
Yeah,
We have another question from Atanas. How graph embeddings and similarity help here? Couldn't we do this with LLM?
Yeah. So that's a very good question. So LLMs have certain limitations. Some of them are mentioned in the slide here, but actually, one of the major issue with using large language models purely for text analytics is the lack of entity linking capabilities of the large language models. So what we are doing during the last few months is that we are heavily researching and productizing actually how to make this integration with large language models and our knowledge graph aware mechanisms for entity linking actually working nicely together. And so what we do is that we usually aim to enhance the response from the large language model with entities from our knowledge graph. So what I showed you here with the tree of dimensions, this is actually achieved on top of the response of the large language model. And this is very important in order to be able to actually place the response of the large language model in context. And to actually be able to use the information that the large language model returns us in a structured way for any additional needs that you might have. So we really need to have this graph representation, which gives us context about the entities that we're interested in and to enhance the large language model response with that. So for this, we use graph embeddings, and thanks to the latest GraphDB release, it becomes even more easier for us to generate these embeddings automatically with the ChatGPT retrieval plugin.
Amazing. Thank you, Krasi. I don't see other questions, but we are just on time. Thank you for your presentation and your overall dedication to the project.
Thank you very much for the attention.
Thank you,
Yeah,
thank you
hope
all,
this was fun.
and we wait you for the next session starting in a couple of seconds. Thank you, Krasi, again.
Thank you.